This is the GitHub Copilot, controlling Power Platform locally. No cloud prompts, no guesswork. Watch what happens next. Before we run into it, you only need 4 things, and most are probably installed. .NET, Visual Studio Code, Power Platform CLI, and GitHub Copilot. If you're missing anything, install it now. Links are in the description. This takes 2 minutes. You'll need .NET 10 or later and Power Platform CLI 1.44 or higher. If you want stability, stick to LTS releases. If you want latest features, go with current, but make sure the versions match. Now install the Power Platform CLI globally. Run your terminal as administrator, then install it using .NET tool command. This command installs the Power Platform CLI onto your computer using .NET. Think of it like adding a tool to your system so you can run the Power Platform commands from any terminal. It automatically installs the latest version available, so you don't need to pick one manually. When it's done, you should see a success message, like tool installed successfully, along with the version number. This step is what unlocks everything. The Power Platform CLI lets your machine talk directly to the Power Platform, so you can create, manage, and automate apps from the command line. Quick check. Type PAC and hit enter. If everything is installed correctly, you'll see a list of available commands. You don't need to learn all of these, just a few key ones. PAC auth is for signing in, PAC org lets you manage environments, and PAC solution is where you'll create and work with solutions. Next, install GitHub Copilot and Visual Studio Code. This is what will actually drive the interaction with the MCP server. Next, install GitHub Copilot and Visual Studio Code. This is what will actually drive the interaction with the MCP server. It turns your editor into an AI assistant interface. So instead of manually writing commands, you can describe what you want in plain language. Now we connect everything. In Visual Studio Code, we add the MCP server configuration. This is what allows Copilot to actually talk to your local Power Platform setup. Now we choose how the MCP server communicates. There are a few options: HTTP, NPM, or command mode. For local setups like this, I use command. As per the documentation, I then add command and arguments exactly as specified. This ensures VS Code starts the MCP server correctly every time. Here's the MCP server configuration. Inside VS Code, we define a server called PAC MCP. We set the type of studio, meaning it runs locally and communicates through the standard input and output. The command is DNX, which is used to execute .NET tools without needing a full project setup. Then we pass the arguments: Microsoft Power App CLI tool with yes to autoconfirm prompts, and Copilot MCP run to start the MCP server in Copilot mode. So in simple terms, this starts the Power Platform CLI in a mode that Copilot can directly talk to. Once saved, VS Code automatically opens up the MCP configuration file called mcp.json. Now we test the setup. I open a fresh GitHub Copilot chat inside VS Code. First real action, authentication. I run PAC auth create, which logs the CLI into your Power Platform environment. This is basically where you give the tool permission to act on your behalf, so it can read and manage resources securely. When you run PAC auth create, it opens a new browser window automatically. Once this completes, you're officially connected. Next, I verify the login. I run PAC auth list in the VS Code terminal. This shows all authenticated profiles on this machine, so you can confirm exactly which environment you're connected to. Now we move into Power Apps, and this is where we actually create something the MCP server can work with. I'll start by creating a solution called Test ALM and select a publisher. This is important because solutions are what Power Platform uses for packaging and moving apps between environments. Inside that solution, I add a Canvas app. This gives us a real application to modify and track. Once the app is inside the solution, anything we change here becomes part of that solution's track components, which is exactly what allows the MCP server to detect and work with those updates later. That's important because solutions don't just store the app, they track every modification we make to it. This is what enables ALM scenarios, and is exactly what allows the MCP server to detect, reference, and work with those updates later in a structured way. Then I add a simple text control and start making visible changes: height, width, fill color, text size, and the text itself. I'm doing this deliberately so the MCP server has something concrete to detect and act on. Without real changes, there's nothing meaningful to observe or automate. So this is a controlled test scenario, something Copilot and the MCP server will later interact with in a visible, verifiable way. This setup is important because it gives us a predictable baseline. So when Copilot interacts with the MCP server later, we can clearly see what exactly changed, where it changed, and confirm that the automation is actually working end to end. Now, I open a second tab showing the target environment. This is where the app would normally be moved to. This is crucial for ALM scenarios because we're simulating a real deployment pipeline between environments. The next step is to now switch back into Visual Studio Code where Copilot already had access to the MCP server through the JSON configuration file we created earlier. What this means is that my prompt isn't just chat, it's being interpreted with real context from the Power Platform via the MCP connection. Copilot can now call CLI commands through the server. My goal here is simple: list all solutions in the default environment, select the one we just created, export it, and then import it into my personal development environment. This is actually a great real-world ALM scenario, and one that Microsoft documents and recommends moving work out of the default environment and into a personal or controlled development environment for proper isolation and governance. So instead of manually running CLI commands, I'm delegating that work to Copilot, which uses the MCP server as the execution layer. This is the real shift, moving away from memorizing commands and stitching together CLI workflows, and instead describing intent in natural language where the system figures out the execution path. It's not just automation or steps anymore, it's abstraction of the entire workflow into a conversation, where the prompt becomes the interface and the MCP server turns that intent directly into action. When I run the prompts, Copilot immediately switches into execution mode and starts interpreting the request using the selected model. In this case, it's set to auto, so Copilot chooses the most appropriate available model dynamically. What you see next is Copilot breaking down the task. It first states that it intends to use the Power Platform CLI tools to enumerate environments. This matches the first step of my prompt. You can actually trace exactly what happens next through the Power Platform CLI output. Each action Copilot decides on is executed as a real CLI command. So you see that environment discovery, solution lookup, export, and import steps appear in the chat. You can see that initially it hits an error, but it doesn't stop the workflow. Instead, it recovers by re-evaluating the available context through the Power Platform CLI and MCP server. From there, it successfully resolves both the source environment and the target development environment. This is important because it shows that the system isn't just executing linear commands. It's able to adjust, retry, and continue the workflow based on live feedback from the tools. You can then see that the next steps from the plan start executing successfully inside the Copilot chat itself. Each action is reflected as it runs, so the chat updates the progress as the workflow advances. You'll notice entries like solution list and solution export appearing directly in the chat output, along with the confirmation messages showing that they completed successfully. Once Copilot completes its response, that's effectively the end of the execution chain. At this point, every step it's planned through the MCP server has already been executed and confirmed through the Power Platform CLI. So what you're seeing here isn't a suggestion anymore. It's a completed workflow that has already interacted with real environments. Now I'll switch back to Power Apps to verify the results. I open the development environment, refresh the view, and I immediately see the test ALM solution has been successfully imported. I continue to open the solution, and then the Canvas app, and inspect the objects to confirm everything came across correctly. Finally, I run the app, and you can see that the text control we modified earlier, along with all the property changes we made. So the full loop is complete. Create, modify, export, and import, all executed through a natural language prompt powered by Copilot and the MCP server.